Nanomaterials are a fascinating field of study that deals with materials and structures at the nanoscale level. The term nano refers to 1 billionth of a meter, or 10 nanometers. At this scale, materials exhibit unique properties and behaviors that differ from their bulk counterparts. One of the most intriguing aspects of nanomaterials is their high surface-to-volume ratio. As the size of a material decreases to the nanoscale, the surface area increases significantly compared to its volume. This characteristic leads to enhanced chemical reactivity and interactions with their surroundings. So for today, we are going to introduce our product, which is a DVD solar panel.
Our product is a DVD solar panel, which the process of making a solar panel is simpler than it would mainly appear. A material that absorbs sunlight and transforms it into electrical energy makes up solar cells. We can make the most of the repurposing potential of basic DVDs for small consumers who have unused DVDs. DVDs are excellent reflector of sunlight. Their shining surfaces can be used to construct solar heating panels or solar power towers. This means that they can help to increase the amount of sunlight that is reflected back into the solar cell, which can help to increase the efficiency of a solar cell. An electrical current is produced when the solar cells on the DVD absorb sunlight. For context, a total of 1.2 millimeters worth of plastics are used to make up a DVD. Polycarbonate plastic injection molding is used to produce each layer. A disc with microscopic bumps arranged as a single, continuous long spiral track on data is created as a result of this procedure. This technique is important for products' physical characteristic and application efficiency.
So these are the materials needed. Number 1, super glue. Number 2, double-sided adhesive tape. Number 3, plywood or plexiglass as a substrate measuring tape. 4, a-couple CDs depending on the size of your window. Number 5, utility. Number 6, pencil. Number 7, Scott-Kai diodes. Number 8, a drops cloth made of clear plastic. Number 9, a few shocks. Number 10, scissors. Number 11, an awl. Number 12, masking tape.
Here are the steps on how to make a DVD solar panel. Step 1. Attach the copper wire to the glossy rear side of the disc. You can do this in many different methods. However, the most common approach is twisting the copper wire into isolated curved sections. Begin by gluing the end portion of the copper wire near the middle hole of the CD. Then spread the copper wire up to the edge of the CD. Create a hairpin bend and return into the middle hole. Redo the same step as you go, in a loop, around the compact disc. Attach the wire as necessary. After every 3 or 4 bends, trim the wire near the middle hole and begin another section. The wire must look like petals surrounding a flower in the end. Step 2. Once the copper wire has been fastened and completely dried, the next step would be to glue the Zener diodes. These are utilized to help in regulating the voltage. Zener diodes must be positioned in the breaches between the cut sections of the copper wire. Solder the edges of the copper wire to the edges of the Zener diodes. Do this using a soldering iron. It is necessary to ensure that one of the breaches is open because you will need to link the insulated wires here later. Step 3. After you have soldered the Zener diodes, you will need to link the insulated electrical wire to your compact disc solar panel. Use a small blade or knife to tidy the very edges of the wire to create a more secure connection. In this step, you will need to utilize the soldering iron again to weld a couple of the copper wire edges to the insulated electrical wire edges. After this, your simple DIY project on how to make a solar cell from CD is done. The next important step is to examine if it is working. Step 4. On a cloudless day, go outside to test if the DIY compact disc solar panel is functioning. Attach your solar panel to the multimeter utilizing the electrical wires and position the CD in direct sun exposure. If your CD solar panel is working accordingly, the meter's reading will rise with direct sun exposure. Alternatively, place the solar panel in shady spot or cover it with an object or your hand to check how the reading responds. Step 5. A base of plexiglass or plywood is prepared. To increase the output and reduce the loss of light, it is recommended to cover the material with a durable dark cloth. The corners of the frame are pre-drilled for fasteners. A soft substrate is placed at the base. This can be thick cardboard, fireboard, or a rubber sheet. Step 6. These are placed on the surface of the base working side up, consistently fixing them with double-sided adhesive tape. Step 7. Connect the elements by placing the solder outputs on the back side of the disc. The connecting connector is connected to the Schottky diodes. Step 8. Lay a transparent sheet of glass or durable plastic on top of the finished reflective panel. Step 9. The entire structure is sealed, taking into account possible modifications to the panel, the need for repair and periodic maintenance. Before the final stage of assembly, it is worth once again checking all fasteners and testing the device for performance. Step 10, or the last step, the front surface of the substrate should be coated with several coats of varnish.
Our product is a cheap approach to start using solar electricity that is made up by recycled DVDs, as it is known that solar panels harnesses the power of the sun, which is virtually limitless source of energy. Unlike fossil fuels, which are finite and contribute to environmental pollution, solar energy offers a clean and renewable alternative. Although we cannot power all of our home's electronic appliances with solar panels constructed from DVDs, they can give us some exploring chances. Despite the fact that it can only give a certain amount of electricity, many individuals choose to run handheld fans or little lights. The wonderful news is that as soon as your solar panel is constructed, sunshine will be the sole source of energy, a low-cost method of producing natural energy that can be used by many, especially those who cannot afford electricity, is capturing solar power through copper lines and DVDs.